Hello everyone, my name is Slav. I'm going to tell you today how to use Jupyter Notebooks at scale within the big enterprises. As usually I like to do things is to start with a problem statement. So what the actual problem, why enterprise even need to consider any best practices that we're going to speak today when they're using notebooks. If you ever worked at any big company or enterprise, you know that this company has a universe of different Jupyter notebooks that are useful. It could be some notebook that represents visualization, analytics. It's useful by itself already. You don't have to rewrite it. You don't have to change anything. It provides business value, and yet it will never see the light of the day of the production. It will never find its way to the actual customers. So the usefulness of notebook kind of lost. And if you look closer to this problem, you will see that inside of the enterprise, there is like another universe of the production grade ready code. It contains special tooling for visualization, special tooling for batch job processing, special tooling for training, special tooling for everything that historically completely incompatible with notebooks. In between, you will have these keepers. It might be DevOps or it might be MLOps or someone that will tell you what are the specific requirements for the production grade solutions code. And only after you will comply with these requirements, your notebook can be finally put in front of the real customers who will get value out of it. And this process usually requires to rewrite source code in order to go from the notebook to just source code. In my experience, this might take weeks, if not months, and we've been hearing this from our customers again and again and again and again. Please help us. We don't want to spend weeks just because something that already has a value need to be rewritten in order to deliver this value to our customers. But this is not all aspect of the problem. The thing is, after you've done this, you deploy something to the production, you start monitoring, you start getting the feedback for this model, and eventually you will need to do another round of prototyping to improve the model. Prototyping means notebooks, means that you have arrived in the right where you started. You arrived at notebook and you need to do rewriting again. So it's not a one-time cost that you're paying once and you're forgetting about it. No, you have to repay it again and again and again with each cycle of the prototyping. So why? Why take weeks? You folks know about the different problems of the notebooks way more than I am. I'm just going to quickly describe you some of them. For example, notebooks allow you executing out of order. It has tons of the secret and hidden state. This is an example that might look crazy for anyone who learned the programming on any meaningful language. But this is actually absolutely valid piece of code for the notebooks perspective. Another thing, notebooks is not aware about any surrounding environment in which the notebook got created. For example, here is an error that I got when executing this line. It's hard to say where this error coming from. Even what this code is related to TensorFlow 2 or 1. Is it something that this TensorFlow is GPU specific or CPU specific? Or maybe this is not even a TensorFlow. Maybe it's another internal library for this company that just called TensorFlow. Notebook by itself has zero knowledge about the environment that creates a problem. And finally, you cannot just put notebook in Git and enable version control system. This is quite interesting and quite fun because even the small changes in notebook like these, so let's say added one line, when I'm trying to use a Git diff and see how the diff see it is a horrible, unreadable situation to be in. Anyway, there is an amazing talk that took place in JupyterCon several years ago, and I would highly recommend to watch it if you have not already. That talk dives much deeper in the reasoning why notebooks are so problematic and why people ending up rewriting code when they're productizing it. I'm not going to dive deep in all the problem, but I will try to articulate some of the solutions. So at the high level, the solution is simple. There are already many other parts of industries in computer science that solve all this problem, and there is many best engineering practice that can be applicable here, and we have created list of things that one should do in order to avoid this problem and in order to simplify a transition from notebook as a prototyping tool to production ready. Here is the 6 item that we're suggesting one need to follow. First is actually the most critical one. All the best practices in software engineering need to be followed. Second one, and the rest actually just follow up from the first one. Each notebook need to be version controlled. Each notebook need to be self-contained and fully reproducible. Notebook need to be covered with continuous integration system. Notebook need to be parameterizable, and notebook finally need to be part of continuous delivery system. We're going to cover today the most important number 4, continuous integration part, and how specifically enterprise solving it on GCP for their need. I'm not saying that if you're going to apply all this to notebooks, suddenly you will go from the prototyping to the production immediately or with all notebooks. No. All I'm saying that from this state, we hopefully can get to this state where some notebooks, this is critical part, some of the notebooks can be delivered as is. Imagine you have a notebook that produces visualization that can be shared with financial department. And this notebook produces visualization. It's value already by itself. You just need to take this notebook, daily execute it, and present to the financial department. You need to have URL that visualizes the result of this daily execution. That's it, nothing else. Yet it's impossible. You have to rewrite it in the way that pluggable in your current infrastructure, current visualization tools, so on and so on. So hopefully, for some notebooks, you can bypass this rewrite and your loop will continue. You're prototyping, experimenting, it's ready, it's passing all the tests, deploy. Now, here is how this pattern often implemented in the GCP. One of the most common high-level architecture looks like this. Here's your user using notebooks, let's say a platform notebooks. And you obviously version control your notebooks. So probably, hopefully they're on the GitHub. And if you're doing any changes after the push, we have a special way to run the cloud build in the way that knows how to pull notebooks, how to parse notebooks to extract the specific environment that was used to author that notebook, and then to dispatch that notebook on the cloud AI platform jobs using exactly the same environment that the author used when the notebook was created, and execute it top to bottom. The status goes back to cloud build propagates it back to the GitHub. And on top of this, it also creates an artifact in the cloud storage. So now with that changes, you can see specifically what the latest green commit, which particular version of the notebook one need to be using, or which particular commit have broke the notebook. So what exactly need to be fixed. Now, with that, let's see several quick demos. Here we have a notebook, fully functional notebook, and I just want to show you how we can execute it through our CI system in a cloud build. I already pushed the special changes. It's just a small changes just to show all the process to avoid waiting until the GitHub cook will start working. So this is our CI, and you can see the step that doing pull, check out specific commit, and finally starting dispatching the job. Here you even can see all the cells being executed and final result being propagated to the Google Cloud Storage with the pass.js notebook CI demo.out. You can use that specific path to actually pull the data from Google Cloud Storage if you want to see the exact notebook that's been executed with all the cells post-populated. So let me show it to you. Here is our notebook, all the cells been post-populated, it's been executed top to bottom, and now this notebook is fully reproducible, it's marked on the GitHub as green. Now let's actually break something. So I'm going to introduce the debugger. It's definitely not Python, it should not work. And I'm going to commit and push all these changes to the mode repository just to show that our CI system will pull, will build, will show you the stack trace, will mark it as red. So here is again the pre-fetch and pre-started, pre-warmed execution of our changes. As we expect, it will pull, build, and show a stack trace. Here is a stack trace. You can even see which particular cell is broken. You can see the stack trace directly from here. And exactly as before, you have a pass, so we can pull that notebook from the Google Cloud Storage to see the stack trace locally ourselves and do the local debugging. Okay, let's do that. So notebook is here in the file system. Let's now open it to see the result. And here we go. As you can see, there is exception. You can scroll to particular cell. Exception is here. Here is the screenshots from the real GitHub. So you can actually go see, check, and reproduce the full setup yourself, because this is a fully functional setup that many of our customers are already utilizing today, and you can start utilizing with some of our services. That's about it. Thank you very much. Here is the link for the continuous integration setup that we just showed to you. And I hope to see and hear from you soon. Thank you. Bye-bye.